Right, a short video here using quotient rule together with standard derivatives and function of a function. This is typical A-level question standard. So let's have a look at number one. Let's say I do y equals the cos of 2x over x, and I say to you differentiate that. Okay, so you're going to realize that this is a quotient of two functions of x. Do not be tempted to divide those x's. You can't do that. The 2x is wrapped up, contained within the cos function, so you can't just cancel x's like that. If it was written as x cos x over x, you could cancel those x's like so, that would be fine. But you can't do that here. This is a quotient. So u equals cos of 2x, v is equal to x. du by dx, well, that requires us to use function of a function. Cos acts first, minus sine of the same angle. Differentiate the 2x, you get 2, and you multiply by that 2, I'll put it at the front. dv by dx is just 1. So quotient rule, dy by dx, remind you of the quotient rule, 1 over v squared, v du by dx minus u dv by dx equals. So 1 over v squared, 1 over v is x, so 1 over x squared, v, x, du by dx, that's this quantity here. So I'll put the minus 2 in front, and then the sine 2x at the end. It's just neater. Minus u, that's cos 2x, I'll leave a gap there, times dv by dx, which is 1. Put that at the front there. Okay, at this stage here, you would be looking at this and say, is there any common factor? Well, the only common factor I can see really is a negative sign, or a negative 1 if you like. But the negative is worth taking out as a common factor. So I'm going to have minus 1. And then this here will be simply positive, as will that be. And probably I would rewrite that now by simply saying minus, change it to a round bracket. Notice I've dropped the 1, it's not needed. And put a big long line underneath the whole thing and put the x squared on the bottom. And that's how I present the answer. Inside that bracket there will not simplify any further. Even if you were to use trig identity work, which we haven't yet looked at, it won't simplify very easily. So there's the answer. Okay, the hardest problem that people find with these questions when you're doing them is, do I stop at that point or do I look to try and continue to simplify it? And really the only thing I can say to you is, the more you do, the more you practice, the more prepped you are, the more you will spot when you stop and when you need to carry on. And for this one, you stop at that point. Well, let's try this one. Let's do y is equal to, I'll do e to the 4x plus 1 all over x. Let's see if we can differentiate that. Again, it's a quotient of two functions of x, so it's the quotient rule. So I'm going to say u is equal to e to the 4x plus 1 and v is equal to x. du by dx is equal to function of a function. Exponential takes priority. Exponential stays the same. And then differentiate 4x plus 1, you get 4, and multiply by the 4. You get that. dv by dx is simple. Again, it's equal to 1. Quotient rule. 1 over v squared. v du by dx minus u dv by dx equals. So it's 1 over v is x, so 1 over x squared. vx du by dx is this thing. Put the 4 at the front, and then the exponential. Take away u. Okay, take away u dv. So u is the exponential, times dv is 1. Put the 1 there, in a bracket if you want. The only thing to do here is to take out a common factor from this term. e to the 4x plus 1 is a common factor. Take it out, times the 1. You just get that. I've still got the x squared on the bottom line. And then I'll now convert to round brackets. I'm left with 4x. That times that gives you that. Take away that times something gives you that. It must be 1. And we get that. Now that's the basic answer. Perhaps, to save a line, I'll just extend that on and have the x squared as appearing just as a single term on the bottom line of one big fraction like that. And there you go. There's that question. Again, a little bit messy, but having done loads of questions, I know that would get you full marks. And you leave it at that point. Let's have a look at a third example then. This one will involve just algebra. Let's see if we can cope with this. I'll use f of x notation. It's 2x plus 1 on the top, all cubed, all over x squared. So we've got a quotient of two functions. So quotient rule to differentiate. U is 2x plus 1 all cubed. So du by dx, when I need it in a minute, will be function acted on by a power. Power to the front. Power goes down by 1. Go inside the bracket, differentiate to get 2, times by the 2. So you're going to end up with 6 lots of 2x plus 1 in a bracket squared. Like so. Okay, v is x squared. So dv by dx is 2x. Let's apply the quotient rule to this. Okay, so the quotient rule to this, it's not dy by dx, it's f dash of x, notice, is 1 over v squared, v du by dx, minus u dv by dx, which is equal to, okay, v is x squared, so this becomes 1 over x squared, which gets squared, so it becomes x to the 4. Square bracket. V is x squared times du by dx, which is this. So I'll put the 6 at the front, and then the 2x plus 1 in a bracket squared at the end. Minus u, that's the 2x plus 1 cubed, times dv by dx, which is 2x, which I'll put at the front. The only thing that requires us to do now is to simplify, and I'm going to do that by taking out a common factor. I can see there's a 2 in both those number terms, times the 1 at the front becomes a 2. There's an x and an x, and there's also a bracket squared and a bracket cubed, so I can take out a bracket squared. I've still got the x to the 4 on the bottom. Now the square brackets I'll change to round brackets. Let's imagine multiplying this out. 2 times, well, I needed 3 to get the 6, x times another x to give the x squared. I've got the bracket squared, so I just need 3x. So that times that gives you that. Minus needed. I've got the 2 and the x, don't need any more, but I've got a power 3 bracket and this is only power 2. So I need a power 1 bracket there. And now finally just tidy this up. 2x, 2x plus 1 squared, and then if I'm taking away this bracket, that is the same thing as 3x, take away 2x, take away 1. Make sure you multiply out both these terms by the minus. 3x take away 2x is 1x, and then minus times the plus 1 is minus 1. So you get that. And then what I'll do is, I'll put one big long line underneath the whole thing and put the x to the 4 on the bottom. And there you go. That's the final answer to that. So no standard derivatives involved in that. It's going to be function and function with quotient rule, and the algebra needs sorting out a little bit. And I think that's where I'll leave this video.